Hi, everyone, and good morning, good afternoon, and good evening from wherever you are joining. Um, Thanks for coming today. So, in this talk, I'll talk about how to build a simple stream processing application with Apache Flink, prominent stream processing engine in the field. I'm Dunit Danushka, and I'm a senior developer advocate from Redpanda Data. If you haven't heard of Redpanda before, it's a streaming data platform that is API compatible with Apache Kafka, and you can also think of it as a drop-in replacement for Apache Kafka as well. So my background is stream processing, real-time analytics, and uh, data engineering. So I've been creating content around these analytics for in these platforms like LinkedIn, Medium, and Twitter as well. So if you have any question or anything related to streaming data, please feel free to reach out to me on these platforms and ask any questions. Right, let's get started. So the plan today is to give you a hands-on experience on how where to get started in Apache Flink. So basically, we have Redpanda as our upstream data source as well as the downstream data sink. So what we are going to do is we are going to write a simple stateless stream processing job, connect it to Redpanda, and we'll see how to build it and deploy it and monitor it from a developer's point of view. So this is more towards developers who are coming from data engineering and application development backgrounds. Before do that, I'll quickly introduce you to stream processing and Apache Flink and Redpanda basic concepts. So if you have any question, feel free to ask me during the uh, presentation. I don't mind. All right. So what is stream processing? I know it's a loaded term, but uh, streams in the stream processing means it's a collection of data points ordered in time. So remember, it's ordered sequence of data points. So each data point in a stream represents an event, or we can call it a change in state of a different, some kind of a system. So for example, you can see a business transaction, something like order being submitted to a web application, or something like a reading coming from an IoT sensor. So all these events, they belong to past and they have two things in common. The timestamp, the time at which the event has occurred, and the payload. Actually, that's the bunch of facts that describes what has happened there. And all these events have a single event source, and that's how you can visualize a stream of events. Stream processing. So this is the practice of processing these streams as they are generated. So that's the specialty. In batch processing, we have data accumulated into some kind of storage, and then we process them on a periodic manner. But in stream processing, we process them as they are generated and as they arrive. So what do you exactly mean by processing? So basically, the idea is you apply some kind of function or processing to each event in the stream. So there can be two variations, like you can either process each event by event. This is what we call simple event processing, or you can do some kind of a complex event processing. So there, what we do is we group events together and we try to derive some sort of patterns or some kind of a rule. So today, our focus is this kind of simple event processing. So uh, that's it. And then the beauty here is with stream processing, you will immediately see the output of the whatever the logic you are applying. Uh, so that's really great for time-sensitive business use cases like fraud detection, real-time monitoring, alerting, and those kind of and real-time recommendations and so on. Uh, if you compare this with batch processing, you see lots of latency in with batch processing. The application we write to build this kind of stream processing application things we call stream processing jobs or stream processing applications, and they continue to run indefinitely. This is opposed to batch processing jobs where we periodically run them. So if I compare stream processing with batch processing, I would say batch processing is easier to understand, easier to implement and easier to explain to, or easier to comprehend to someone else, because we are dealing with a finite amount of data. So say, for example, if my batch job fails in the middle of something, and then I can always correct it and rerun the data set, because uh, I know the boundary of data. But with stream processing, our input data set is unbounded, and it's never ending. You can't say this is my boundary. This is the last event of the stream. You can't say that. Because of that, stream processing applications is challenging, because these applications needs to be running all the time, and that means you need to think about high availability, fault tolerance, and load balancing and many other infrastructure level things. So, for example, if you are dealing with some kind of a stateful aggregations like counting events or uh, doing some kind of a join or something like that, then you have to deal with the state. State means you have to make sure it's not lost, uh, and then you have to replicate it properly, and there are so many complicated scenarios. So if you are a typical developer or a data engineer who wish to write a simple stream processing job, this is too much. So that's why people came up with these stream processing engines. So basically, stream processing engine is some kind of a data middleware, or it's kind of a infrastructure component that does this heavy lifting for you. So this is where we meet Flink. Apache Flink is a stream processing engine, and then we can categorize it as a data processing framework that is capable of batch processing as well as stream processing. I see most people use it for stream processing, a reliable solution for stream processing. Flink is an Apache project, and it's open source, and the source is freely available. But I can see there are many Flink as a service, commercial vendors and commercial Flink distributions in the market as well. Uh, you can also get into this involved in Flink. It's a vibrant ecosystem. And so it's also battle tested. You can see, you might see large Flink deployments in companies like Netflix, Uber, and many more. So before I talk about Flink and before I get into the details, uh, let me touch upon this operation model of Flink. So this is where I talk about data flow programming, because this is where we should try to understand how Flink works. So basically, data flow programming it's like uh, so in this model you have a graph. This is a DAG. We call it directed acyclic graph. So in here you have collection of nodes and edges. Each node represents some kind of a computation logic. So this could be something like a function, aggregation, counting operation, or something like that. And then we have edges that represent different data flow in between these nodes. So basically, this model works. One node receive data from one component, and the do some processing, and the output is emitted to the next immediate node in the graph. But why should we consider about these jobs, DAG graph? Because you as a developer, you don't directly program against this uh, data flow model. You don't write data flow application. You write some kind of a simple API program, and then it's up to the Flink to convert this into uh, data flow model. So data flow model. So this is what we call physical job graph. Any question? Luna?
Свои dependencies. Поэтому нужно их сюда добавить. Отлично.
Я понял. То есть в рукопашную их сюда нужно.
Да.
All right. So I see a
I've got a question,
Does Kafka
if
use
you don't
Flink?
mind.
So that's a good question. Basically, um, right. So basically, Kafka uses Flink. So that's a good question. I'll come to that shortly. But the short answer is Kafka is a complementary part to Flink, and Kafka is a standalone system. But Flink is more of like an engine that can consume data from Kafka as well as write data to Kafka. I'll show that interaction when I get to the demo. That's a good question. Right. Okay, so that's about data flow programming. So yeah, so there's another question. Is save to database an operation that could be handled via Flink? Good question. Yes, Flink is capable of saving records to database via a special construct called connectors. So there are like sync connectors available in Flink. So there are like JDBC connectors. So if your database is JDBC one, it can you can save events to that. Can be parallelized is state shared between job instances. Uh, uh, yeah, yes and no. So basically, if you parallelize one, so basically we can parallelize stateless operations. That means mostly like mapping, transformation, filtering, we can easily parallelize them. But yes, if you are dealing with state, that can also be parallelized. Then the input data set has to be partitioned across different nodes. Right? Moving on. Okay, so let's try to understand what's under the hood of Flink. So basically, Flink is a complex distributed system made of two critical components, job manager and the task manager. Typically in a Flink cluster, we call it a cluster. When we start all these components, it forms a Flink cluster. And then in a typical Flink cluster, we have a single job manager and multiple instances of task managers for high availability. And then we have clients who can submit jobs to this job manager. So that's the overall topology of a Flink cluster. Um, the thing is, this Flink is written on top of a JVM, or Flink runtime is Java based. So that's the specialty here. And then when you come, but your client application can be anything, something like a SQL client. So there are, and then it can be Flink Python application. So it doesn't matter. So what Flink offers you is some kind of an interface to submit your Flink stream processing application. For example, if you like declarative style SQL programming, then you can use Flink SQL, which is kind of a different application model, which I'll cover shortly. And then if you like Python, if you like to write your application with Python, you can use PyFlink. You can write your application and submit it to Flink cluster. And then there are a few other options like CLI, just want to interact with your cluster as well. Like I said, the Flink runtime is JVM, but it doesn't hold you off if you are not coming from a Java background. So basically, it supports Python and SQL programming languages as well. So the role of job manager is to accept this stream processing application from these different clients and convert it to the physical job graph, that data flow model I mentioned earlier, and then submit it to or schedule it to different task manager slots. So the way that works is these task managers are like they are like runtimes, and they have compute separate storage and networking. So they can be virtual machines, they can be something like containers, or even some serverless kind of appliances. So they have a CPU and processing power as well. So what
Yeah, must you cancel.
So what Job Manager does is it maps this application into different task slots that are available in this Task Manager and schedules these tasks uh, in different Task Manager deployments. And then if, let's say, if this first Task Manager fails or crashes, the Job Manager, uh, it can detect the failure here via a heartbeat, and then it can reschedule the failed Task Manager's task slots in a different task manager. So that way, Flink can guarantee the fault tolerance or the reliability of your stream processing application. All right. I think you might have got a fair knowledge and introduction to Apache Flink. If you have any questions, I can take few, and then I'll switch gears and go to the demo. there's a question about are there situations where we might lose events due to failure? With Flink, it's very rarely because that's what I just explained. So Flink has many fault tolerant mechanisms like, state checkpointing and heartbeats. So I haven't seen Flink losing events due to failures because of the Flink's architecture, the way it works, Flink can uh, reschedule its failed jobs so that it can resume from the where it last stopped, last processed. All right, so what we are going to do here is we are going to write a simple stateless stream processing application with Flink. So what we see here is a Redpanda. Redpanda, if you are familiar with Kafka, basically Redpanda works in the same way, but in much more simpler and faster and cost-efficient manner. So in Redpanda, we have two topics, orders row, this is our source topic, and the orders topic, this is our destination topic. So what I'm going to do is I'm going to generate a simple Flink application and configure it with right amount of Maven dependencies, and I'll let it consume events from orders row topic and do some processing in the middle, and I'll write the process data back to Redpanda orders topic. Very simple one. I'll walk you through the ideal, typical developer experience here. So what you need, so basically to make things simple, I deployed everything in Docker Compose. I'll share the link to this GitHub repo and the slides after the event. So I have Docker Compose running in my local machine. For example, this is my local Docker Compose file. If you can see, let me know if you can see this, if you can read these text fonts. I'll try to make it them bigger. So basically, the layout of this file is I have few containers running. So I have Redpanda. This is my broker here. And then I have Flink's job manager component here. It runs on port 8081. And then I have the task manager, single instance of task manager. And then I have console. So basically this is Redpanda console. This is an optional component, but I use it here just to make my life easier when I try to develop applications with Kafka and Flink. Question about, is there a GitHub repo with the sample code? Yes, I'll push this code to GitHub and I'll share this with in the meetup meetup page. I'll put a comment with the sample code. And I believe the recording will be uploaded to YouTube as well. So yeah. Right, now let me start them. And there's another question, is Flink for data transformation and back pressure relief? Yes, for both. So Flink is not only for data transformation, it can do data aggregation, and it can do some kind of a event by event processing. You can write some kind of application, reactive application as well. And then regarding back pressure relief, yes, I think I'm not too sure about how it does that internally, but Flink has built-in construct to deal with back pressure. That means without affecting your application's performance. Okay, what I'm gonna do is I'm gonna Docker compose up. So looks like I have just started my cluster, Flink cluster and Redpanda cluster. In my Redpanda cluster, I only have single node, single broker. And yeah, it looks like it's all good, but let me open my browser and see whether Redpanda is running. The easiest way to make sure the Redpanda is running, I'm going to Redpanda console. So it says it's there. And just to make sure Flink is running, up and running, I'm going to Flink UI, and you can see Flink dashboard here. It's localhost 8081. So you can see visually. I'll get to this in a later slide, but first of all, I have a few things to do. So this is the Redpanda console. You see, this is the web UI that I use to interact and work with my Redpanda cluster. So the beauty is uh, you can use this console to work with any Apache Kafka compatible streaming data platform. It could be open source Kafka, or it could be any Kafka as a service or managed Kafka offering. It doesn't matter. So what this Redpanda console offers me is the complete monitoring details, observability. I can see my topics as well. Um, so I'm gonna delete them for now. I can see the schema registry. There's a built-in schema registry, which I haven't configured here. And then you can see the consumer groups. You can also administer your security policies. You can define user accounts. You can also attach access control policies or ACLs to users. And there are many more. If you are interested, you can, this is freely available, by the way. You can check it from redpanda.com. Okay, what I'm going to do here is I'm going to create two topics for my demo. One is orders row. So basically, this is my UI interface. But if you are familiar with or comfortable with working with a CLI like KCAT, this is also possible. And here I can specify number of partitions. I'll leave it to as defaults. Cleanup policy, I'll leave them as default values. Okay, I have my source topic now. So this is basically my source topic. I need another topic. Let's call it orders. It's going to be my uh, destination topic. So the beauty of console is you can go into these topics and you can see the contents of the topic inside. So let's hydrate this orders row topic. What I'm going to do is I'm going to go back to my terminal and produce 10 JSON events. So let me copy that command. So basically, I'm using a CLI again. So this is Kafka Cat or KCAT if you are familiar with it. If you don't, then you can use any CLI like Kafka console, Kafka topics application or anything. So basically, this is my Redpanda broker address, and this is topic. And I'm producing these topics data from this orders JSON file, which I can find it inside my here. So have a look at the structure of this. So each row represents a simple JSON order, ID, amount, region, timestamp, and everything. So what I'm going to do is I'm going to transform the value of this region attribute to uppercase in this job. So before that, let me produce this to Redpanda. There we go. So here, the nice thing is you can always go back to this orders topic and see the look and feel of this JSON event. I can see whether it's good or bad. So this is really helpful if you are developing application and you want to debug why your message is not showing up in Kafka topic. So basically, this is a good way to do that. All right. Did I miss anything? No. All right. So now I have the necessary data infrastructure. I have my data source, Redpanda broker, and then I have Flink cluster up and running. So what I'm going to do is I'm going to write a simple application. So this is where we talk about Flink's different API layers, so API abstraction. So like I said in the beginning, as a developer, you don't really want to manipulate these data flow programs. So it's up to Flink to offer you different levels of API abstractions in Java. Basically, it comes in Java and Scala. So you can pick and choose the right level of abstraction that you want to deal with. For example, you can think this API abstraction like as a layer cake. The bottom two, data stream and process function, they are like more low level, while you can see more high level declarative API abstraction in the top layer. Basically, when you go down, you will have more expressiveness and more power in your programs, while when you go up, you have more conciseness and declarativity at the top. So basically, what we are going to do is we'll write our program with data stream API, which is a low-level API. This is what you see. This is a sample of data stream API code sample from a typical example. Uh, the thing is, this is imperative. This is that means you will have to tell Flink how to do that. This is like you are giving like procedural instruction, like line by line. This is how you do that. But if you use different types of API abstraction like Flink SQL or Flink's table APIs, you will get more declarative approach. This is where you tell Flink what needs to be done instead of telling it how it should be done. So for example, this table API gives you more like a pandas, like a data frame, like a experience. And if you don't like table API, then you can go with Flink SQL, where this is where you will get a standard SQL-like environment to write your Flink application. But Flink anyway gives you freedom of using either table API or data stream API. So the bottom line is, if you need more declaratively, go with high-level table API or SQL, and go with data stream. If you need to write more complicated applications that deals with state and time. And also, Flink gives you the ability to mix these two APIs together in a single project as well. Okay, now I'm going to do is I'm going to generate a simple Java project. This is going to be my skeleton application. In order to do that, I need Java 11 or higher on my local workstation. I need Maven 3 as my dependency manager. And then I need some kind of an IDE, something like IntelliJ or Eclipse. Let me check some questions before that. Can you use VS Code? Of course, good question. Yes. My favorite IDE is IntelliJ. That's why I'm pulling it out. Right, let me check few other questions as well. Does Flink have a queue? Can it replay or resend messages? I'm afraid no. Flink is not designed as a queuing mechanism. If you want to use a queue, you should always go for a message broker, something like RabbitMQ or Nats or some kind of thing. But if you want to replay or reconsume, it's up to Flink. But so basically, Flink can maintain if Flink consumes from a Kafka topic, it can maintain its offsets. It can commit offsets, and the Kafka can maintain its offsets in a different topic. So, like I said, if you are writing a Flink application with Java, there will be lots of dependencies, and there can be many versions and many transitive dependencies and many things. So maintaining it over time will be really hard. So that's why Flink project provides you with a couple of Maven archetypes. So basically, it's like a template or kind of a boilerplate stuff that you can generate a minimal project with essential dependencies. So that's what I'm going to do now. I'm going to generate a simple project here. I'll explain the each and every flag as we go. So this archetype will generate a project with these. These are like self-explanatory: group ID, artifact ID, the version. So basically, archetype version ID is 116. So basically, this will map to the corresponding Flink version will be using. Right now, it will be the Flink latest version, I think 119, but I'll happy to stay with 116. And I'm setting interactive mode false. That means it will generate the whole thing in one go. But if you set it to true, Flink will ask you this information interactively. There we go. And I think we have now two projects, Flink Quick Start project, right under this project. So what I'm going to do is I'm going to quickly import this into my IDE. You can, I'm not going biased towards IntelliJ, but this can be anything like Eclipse, VS Code, it could be Vim, but I like the developer experience here. This is my Flink Quick Start project, and there's a form file generated. If you are using a different ID, these settings might be quite different. But I'll walk you through the initial setup of this project. So basically, this archetype generated me a POM file with necessary dependencies, like I mentioned. So you can see the Flink version set up as 116. You can change it, go ahead and change it to whatever the version you would like to work with. And the most importantly, Flink, this generator has already included the necessary dependencies for my client SDK. So basically, since I'm using the data streaming API, it has already included the Flink streaming Java components there. If you need more dependencies like connectors and those kind of things, this is the place you should include it, dependency section. And the others are like auto generator, and most of the time you don't have to touch them. Basically, what these build plugins do is it will compile them and package them into a single Uber jar, one giant file with many jar dependencies here. And then you can take it out and you can deploy it to the Flink cluster. All right. That's it. And then moving on to the next section. Okay. Now I have a skeletal project generated. Now I want to write a stateless operation, simple stateless operation. So what are stateless operations? So basically, stateless operations, they observe events without historical context. That means they don't remember their previous execution. Actually, the result of the previous execution is not maintained. It's not remembered. So that's why they are called stateless operations. So they don't require much memory requirements, and then they are lightweight because there's no dealing with the states, simpler to deploy easily. You can also parallelize them easily. You can scale multiple applications of them uh, because of that. So in a typical stream processing application, you will build uh, streaming data pipelines. So we call it streaming ETL pipeline. What you do is you will do some kind of a stateless transformations, like you will filter out certain events of incoming stream and map it to a different uh, output stream, something like cleaning your data. And then you will scrub uh, uh, sensitive or PI data from your events, and you will mask them with appropriate fields. And then you can also take one event and transform or convert it to a different event format, like JSON to XML conversion or something like that. So this is where we use stateless operations most of the time. In this session, I'll only talk about stateless operations, but Flink is more than capable of doing stateless and stateful operations. In fact, Flink is really good at doing stateful operations, but due to this time, I don't have much time to cover all the stateful operations, but I'll make sure to walk you through the development lifecycle here. Right. Let me right now, let me go back to my ID. Yeah, so this is the skeletal project. So what I did was to save our time, I already created order processing job. Let me load it. This is basically the same job, but with different dependencies. I'll show you the dependencies I have added. So basically, this is the same form file as you can see. The structure is same. Only differences here is the different dependencies here. You can see this is the same data streams API. And then in addition to that, I have these two dependencies here. Basically, these are called connector dependencies so I'll start with Kafka connector because I want to consume data from Redpanda as well as I want to write data to Redpanda. So since Redpanda is Kafka API compatible, I can use this Flink connector Kafka dependency here. So that's why I included it here. And then the input, as you can remember, if you see the format of the events, it's JSON formatted. So Flink doesn't know how to decode this JSON data. So that's why I included this format. So basically, this is a format. So Flink support different types of formats to decode or deserialize your data and serialize them as well, like Arrow, JSON, XML, and so that's why I included Flink JSON here. And then this job is simply a Java class. So what it does is, so I have this main method here and few other complementary methods. I'll collapse them just to make it simpler for you. So inside the main method, what I do is I initiate my streaming execution environment, and then I build a Kafka source, set my topic as orders row, and then I set my serializer and deserializer as well. So what I'm trying to do is I'm gonna read the record from orders row topic, convert it to this orders pojo here. You see, this is a simple pojo file. This is automatically done for me by Flink, this connector format, JSON. So this is what you can use for that. And this is going to be my target data sync. So again, the target data format is an order, but with a different structure, few internal changes. So this is where the magic happens. This is where you do your processing. So basically, uh, I read from a source. So this is like a DSL. You can see I read from the source. I set no watermark. So basically, watermark, this is kind of an advanced concept in Flink. That means uh, you tell Flink to wait for late arriving events for a certain amount of time. But in this case, I don't want to wait for late arriving events. I just want to process them immediately. And then I have a new map operation here. So what this map operation does is it can transform this order object into uppercase. So basically the operation is here. So at this point, I'm getting a hydrated order pojo. And then what I'm going to do is I'm going to return a new order pojo with the region converted to uppercase. So that's the logic of my application. This is really simple. So how would you deploy this? So this is where the interesting things happen. I go to order processing job, simple Maven project. So in order to deploy this, I want to compile this Java application, build Uber jar, and then generate a final jar file. In order to do that, I execute mvn clean package. My project is being built now. And then if you go to order processing job here, you can see two jar files. So one, this is the jar with all the dependencies included. What I'm going to do is I'm going to deploy this to my already up and running Flink cluster. So if you haven't already visited here, this is the Flink dashboard or Flink UI. So this is where you interact with your Flink cluster. Just like Redpanda console, this is your UI-based approach to manage your Flink cluster. You can see the running jobs, completed jobs, and then you can see task manager information. Since I only have one task manager, I can see it here. You can see the details of your job manager. Most importantly, what I want to do right now is submit a new job. Can add new file. I think this is it. Select this one, and then here you can pass some program arguments. Parallelism, you can also use save point. So basically, save point is like a place where you save the state of your application so that you can resume from there. So advanced concept, we don't need it here. Just submit it. And give it some time, like few seconds, and Flink will convert this into physical job graph and deploy it across all the task manager instances. Okay, so looks like my job is running. So if you go back to overview, you can see this job is running. So if there's a failure or some kind of error, you can see that in exception, but for now, there's no exceptions. And then there will be checkpoints and different, you can see them here. It's a really good application. Okay, so how do we confirm whether my application does the thing that it's supposed to do? So basically, if I go back to my Redpanda topics, I have two topics, or this is my raw topic, so input topic. And then if I go back to my orders topic, yes, it is already populated. And I can exactly see 10 events in the target. And then I can see the region has been transformed to uppercase. Every region field of every event has been transformed to uppercase. So that's what my job is supposed to do. That means it is successful. So that's the developer workflow. So that's one thing I would like to add. So basically, what if you want to alter your program? You want to make a change, and how would you redeploy? So that's an interesting workflow for developer. So basically, the next step is I need to add a filter operation. So basically, let's say this is a map operation, and I want to filter out all the orders that are not coming from LATAM region. So this implementation has already been done. So basically what I'm doing is I'm just checking whether the orders region is LATAM, and if it is LATAM, I'm going to ignore it. So in order to do that, what I can do is I can add a Flink filter operation here. That's it. And then as a developer, I need to rebuild it and redeploy. Let's do that. Okay, this is already running. So I'm going to deploy another version of this job. I'm going to delete it. I mean, this is not the ideal approach. So there are ways like Git-based workflows that if you deploy this to in a Kubernetes and production environment, there are people use different workflows to version and deploy new versions of these jobs. But I'll stick to the simplest version here. Let's give it some time. In the meantime, I'll submit another batch of these records. Let's go back to the orders row topic, and let me publish the same data set again, so that now I will have 20 records here. Okay. You can see there are 20 records, but looks like the second job also running. So ideally I should have orders topic. Yes. So if I order from my offset, higher offset means recent data. You can also see the timestamp. And if you check the content, you should not see any event from LATAM. Yeah. So that's how we deploy a new version to Flink. All right. I think that's all I wanted to cover today. Just So if you want to learn more about Flink, we have a free Flink course at Redpanda University. So you can always visit university.redpanda.com and you can sign up and enroll for an advanced Flink course. There we cover the essentials of stream processing with Flink and how you can build stateful and stateless workflows with uh, combining it with Redpanda. So if you have any questions, I'd like to have answer them. Right. So if you have any questions, I can take some. Otherwise, we can wrap up for the day. And the recording will be posted post-event, and it will be available on Big Data Demystified YouTube channel as well, I think. I see a few questions coming in. What is the GitHub link? I haven't checked in my code yet, but uh, I'll check in my code in my GitHub repo, and I'll post a link in the meetup page. So I'll post a comment there, so you can find it there. There's another question about is Redpanda hosted service for Flink and Kafka? So basically, Redpanda is a Kafka replacement. So yes, Redpanda can be a hosted service. Redpanda offers self-hosted deployments, and Redpanda offers serverless and fully managed services as well. So if you have already using Kafka, so the Redpanda can be a replacement without changing your code. Good question. Again, does Redpanda has a free tier SKU to experiment? Yes, like you said, there's a serverless trial we offer you for 14 days. You can you can experience all the features there by signing it up. It's absolutely free. And there's a community edition. We offer Kubernetes and Docker Compose images. You can use it for development purposes as well. And there's another question, I think, if I create a table with count of messages that have the fields in the last 10 minutes, can another Flink task use the table? Yes, of course. Yes, I believe that's possible. It's Redpanda and there's another question. What kind of delivery guarantees does Flink support? Yes, Flink is known for its exactly once semantics, and I believe that Flink guarantees that an event is delivered to its recipient once and exactly once. So that's a strong guarantee. That's really hard to implement with typical stream processing engines. There's another question. Since Flink is not for PubSub, does that mean you use Kafka if you need topics and PubSub? So basically, think of Flink as a consumer for your PubSub, and if you need PubSub or some kind of messaging features, you have to couple Flink with your message broker. So this could be This could be something like Kafka, or it could be something like RabbitMQ, Nats, or any other thing. What Flink does is it consumes messages and it does the processing. So basically, uh, in this case, if you have topic, then you can write two Flink application. So for example, let's say you are processing notification. One Flink application can do some kind of processing with notifications, like writing it to a database. And while at the same time, the other application can write it to some kind of a thing like triggering an alarm or something like that. So it's basically it, Flink doesn't know whether it's pubs up or queue, so it's up to the messaging layer. Regarding the table, where would that get stored for other tasks to use? So yeah, that's a good question. So basically, this is where this checkpointing coming. So basically, Flink stores its task state locally. So this local state is usually written using RocksDB, if you are familiar with it. Yes, if you have worked with KSQL I think that also uses RocksDB underneath. And also, Flink offers this concept of state stores. That means you can also extend your state to some kind of external uh, persistent database, some kind of a thing, or some kind of a network attached storage for more persistence. If they, I believe, not too sure whether Redis is supported as a state store, but need to check out. But the underlying concept is if you need your state to be persist to in external storage, that is possible through state store backends. And you can check whether Flink provide these service provider interfaces for Redis or so any supported technology. I believe I answered all your questions. Like I said in the beginning, if you have any questions or clarity, any clarification, reach out to me in uh, my LinkedIn. So you can search me on LinkedIn. And so basically, I'm posting it here if you need any clarification. I see one more question. Let me take it before we go. Does the sync pull messages or the Flink call the sync to get its messages? I think it should be a source, I believe. Either way, it's up to the source implementation. So basically in this Kafka scenario, the source pulls messages from Kafka partition. So then and also regarding the sync, also it's up to the sync implementation. Some syncs they can pull or push messages to uh, downstream system. It's up to the implementation. There's one more question. What is the Redpanda strong point versus Kafka? Again, good question. It's the performance because it's a different runtime because Kafka is based on JVM and Redpanda is based on C++. That means it can work more closer to the hardware, native hardware, and extract most out of its uh, performance, like more CPUs and more uh, new next generation network cards. And that's the performance. And then simplicity, because Redpanda by design, it's free of Zookeeper and it uses its own RAF uh, algorithm implementation. So that means uh, less component to worry about. Also, Redpanda comes in a single binary architecture. That means it bakes in all uh, the usual essentials you need to get up and running with a streaming data platform like the broker, schema registry, HTTP proxy, Raft engine, and everything comes in a single runtime. So you don't have to manage them and deploy them separately. Yes, so that's a good question. So the Redpanda does not use a Kafka source code. Yes, it's a it's not a it's not a clone, Kafka fork or a clone. It's not a Kafka fork. It's a rewrite in C++. It uses a different code base. It's written in C++. I think we are running out of time. If you have question, reach out to me. I'll make sure to publish the source link to the GitHub repo in the comments. Also, I'll publish the slide deck in the comments as well. And thanks for your time and thanks for joining. Hope you enjoyed the session. Thank you. Have a good day.